Thank you. First of all, thanks for those of you that came early. I'm sorry for the delay. Really appreciate you bearing with us. And thank you as well, again, to iHub for being generous in hosting this space and this talk. So before I start, basically today I'm just going to be talking about what Benshi is doing, our work, and where we hope to go. But before I start, I'd like to quickly introduce myself first. My name is Madhav Nekkar. I'm a data scientist at Benshi, and I have a little bit of an unconventional background. I studied economics at the University of California, Berkeley, and so I don't really know anything about finance or investments. Don't ask me about that. I really was drawn to economics more from thinking about social problems from a quantitative lens, and that lended itself very well to data science and econometrics. And at the same time, I'm actually headed to medical school in the fall. That's perhaps a little bit surprising to some of you because unlike in Kenya or in India where my parents are from or Europe, much of the rest of the world, you do not start in America medical school right after high school, right after 12th. You have to first complete an undergraduate degree and then you go into medicine. And so during this application process, I'm someone who, my parents are from India and my grandfathers were doctors. And so I had the privilege of being able to visit India a lot while growing up. And I saw very visible health inequalities as a child growing up. So global health has been something that I've been very passionate about and has been on the front of my mind for a long time. And at the same time, I'm from Silicon Valley. That's where I was born and raised. And so I've seen both the power of technology and the harm that technology can do. And I've been interested in how technology can improve health. And all of those sorts of interests have brought me to Benshi, where I continue to hope to stay involved while I go back to more school. Just to give a quick overview of today, I'm going to be kind of talking about, at a high level, our vision and mission, and also how what we're doing today translates to the current issues that are being faced in the space, and then talking a little bit about what we're working on and what exactly our platform does, what our platform is all about. And then going to talk a little bit more about, at a higher level, our team, the kinds of research that we're doing, and kind of wrapping things up with a quick case study on malaria, which hopefully is interesting to you all. So the vision of Benshi is to use digital data and machine learning to reduce global inequalities. That's at a very high level what we're hoping to do. I have 2 slides on missions because I think what we're trying to do it can be described in many different ways. So at one level, again, we're trying to bring operational machine learning and make it accessible to all organizations that exist in low and middle income countries. And the way that we're doing this, also another slide on the mission, is to provide real-time and just-in-time interventions. So these can be nudges or incentives that are personalized to different stakeholders, from the level of frontline healthcare workers, patients, regional health officers, hospitals, at all levels. So what is the current issue? What is the current landscape? The reality is that there's a growing market of mobile health applications and tools across low and middle income countries. Being in Nairobi, I'm sure you are all very aware of this. Many organizations, both based in the West and based across the global South, are developing apps for use by these various stakeholders. And that means that when people are using these apps, right, there's increasingly higher penetration of smartphones, other mobile tools. And so when people are using these apps, those apps are collecting data. Anytime you log on to WhatsApp, or you send a message to someone, or you record a voice note, all of that data is being tracked by someone. And the same thing is true for all of these mobile health applications. However, many of these organizations don't have the advanced data science and machine learning infrastructure that we think of when we imagine large tech companies in Silicon Valley. So for example, Netflix or Google or Facebook or Amazon that have those capabilities as well. And so what that means is, even though that there's more a shift to a digital medium, there's still an untapped potential of that user behavior data. And we're still using one-size-fits-all interventions. And that's where Benshi is hoping to come in and make a difference. So our goal is to provide useful and actionable information to understand behavior. We hope to understand each user in the way that they're using mobile applications. We then, based on that understanding, hope to predict future outcomes. And based on those predictions, we hope to intervene, to take action and nudge behavior in order to promote health outcomes. So the way we do this is through our product, which is a data-centric and behavioral machine learning platform, again, geared for and designed for low and middle income countries. What exactly do I mean by this? I want to sort of hone in on both parts of what I just mentioned. The first is data-centric AI. And I want to kind of make this distinction between data-centric AI and model-centric AI, which are sort of terminologies that have become more and more commonly used in the machine learning and artificial intelligence community. And that is that historically, artificial intelligence experts have been extremely motivated from a model-centered perspective. So that means that there are people that they have very advanced degrees in math, and of course, all of this requires very high level of mathematics regardless, but they're very focused on tuning models to fit certain specifications and to make sure that the parameters that they're inputting are correct. But while obviously a model, your model needs to be good, that's obviously true, but that has often come at the expense of a data-centric approach or thinking about the data. And so we want to really bring out front and center that the data is what makes the model successful or not the other way around. And by that I mean, again, you might have heard this phrase sort of garbage in, garbage out, which is very, very common in the technology industry. And that is that if you're not collecting and recording high quality data or even useful data, then you're not going to be able to generate meaningful predictions. And so that's really like where our emphasis comes in terms of tracking the high quality data. So even before we really partner with an organization and start running these interventions, we oftentimes spend several weeks doing a data audit, just letting them know, okay, what is the data they're collecting? Could they be collecting it in a different way? Are there things that they're ignoring that could be very insightful if they started tracking that? And we found that those conversations, before we even do any machine learning or artificial intelligence, those conversations have had tremendous value for a lot of our partners. And in tracking that data, we want to organize it in a way that is friendly for machine learning. So oftentimes we've found that our partners, they're sort of just tracking data in a haphazard way, or it's being recorded that way because that's the way that it's been done without a lot of thought. And so what we're doing is translating that pattern that way of organizing it into something that is useful to then generate insights and actually conduct machine learning on. And then I want to talk about the second component, which is the behavioral machine learning. And the idea here is that we can send interventions that are adaptive and just in time to a given situation, right? And so rather than sending something that is one size fits all, we want to hone in on what makes each individual or individual user tick. So how do we do this? We're doing this sort of through a couple of different types of data. Again, data is like our oil, so it's really the most important thing. The first thing that we're thinking about is the logs of the applications. So this is telling us how a user, each individual user, is interacting with the app. It could be that this is someone who is a nurse who only uses the application late at night because they're having to, they have a busy day at work, they have to come home, they're taking care of their kids, or they're doing housework, and they're only able to use the application at night. So for that kind of a user, we wouldn't send them an intervention or a nudge in the middle of the day, right? And this is just a very basic example, but trying to get at what I'm highlighting. I'll go more into depth on that in a couple of slides. Along with the logs from the apps, we're also thinking about patient health profiles as well, sort of thinking about it from that unique user perspective. At the same time, it's also really, really important to have the broader context in which a user is using an application. So this can come in many, many different ways, but let me give you an example on, for example, the climate, right? So if it's pouring rain outside, and we know that it's pouring rain outside, it doesn't really make sense to try to get someone to walk a mile if you were trying to incentivize somebody to have healthy behavior, as an example. Or in the context of a supply chain issue, right? So if we know that it's going to be severe weather events, we need to take that into consideration in the models. It cannot just be based on what people are asking for, right? So of course we need that logs from the applications. We need that user insight. We also have to think about that broader context. That's what I'm trying to highlight here. I want to touch, again, on that same note about the data. We're primarily working right now with time series data. So again, that's from all the what I just mentioned on the previous slide. But we're hoping to expand into more image-based analysis as well in the future. This can be sort of images of things like rapid diagnostic tests or other healthcare scans and images. It could also be sort of looking at manual, like images from the supply chain context, so converting manual supply chains into digital logs. And we're also thinking about satellite imagery, as I alluded to earlier, in the context of some of the climate events, which are increasingly tied to health events. So our company right now, we're mainly focused on healthcare, and we're also focused on supply chain as well. And I want to highlight why these two areas are what we're working on currently. The main reason for healthcare is that, so we're primarily funded by the Bill and Melinda Gates Foundation, and their sort of main mission is to reduce global health inequalities. And so because of that, that's the main purpose with which we were founded. But at the same time, the context in which we're thinking about healthcare is, for example, for building capacity among midwives, or supporting frontline healthcare workers by sending them direct interventions. And that sort of behavioral machine learning is something that our founding team has had a lot of expertise in. So before starting Benshi, our CEO and the CTO, several other senior leaders in data science, they first worked in Japan on video game player behavior, where again, it's the same kind of concept of behavioral machine learning, except in a totally different industry. And so that's where our interest in these personalized interventions comes from. And then after working there, they were actually in Spain working for Inditex, which is the parent company of the fashion brand Zara, you might be familiar with. And Zara is one of the world's largest supply chains. And so actually our CEO Africa was the chief analytics officer at Zara before founding Benshi. And so that's why, because of the sort of goals of our funders and the expertise of our founders, healthcare and supply chain are the most natural areas for us to begin working on right now. Although eventually we do want, again, going back to that vision statement earlier, we do want to reduce global inequalities in general, and we know that getting into more verticals, so for example, agricultural and financial services down the line, not necessarily tomorrow, is something that we are looking towards. Within healthcare, we're looking at a couple of different specific areas right now. The first is maternal care. So we're partnering with an organization called the Maternity Foundation, and they have developed an app. It's called the Safe Delivery app. And actually, there's people in my parents' home district in rural India that are using this app, so it's really cool for me to work on it. There's also lots of users of this app in Kenya, in Ghana, across South Asia, Sub-Saharan Africa, and Southeast Asia as well. And the idea is, can we improve the capacity and improve the skills, knowledge, and training of midwives, nurses, and other skilled birth attendants as a way to combat maternal mortality? And so you can think of this app sort of as a Duolingo or a learning app for healthcare workers. And what we're trying to do is get them to deepen the impact of this application by getting them to watch more content, take more quizzes, and essentially improve their skills. So just like YouTube is recommending you a video that you're going to watch, and you go down this rabbit hole and you keep watching YouTube videos, that's what we're trying to do, except for public health and for social good. In the context of pharmacies, we're also working with an organization that is based in Southeast Asia, so mostly Indonesia and Thailand as well, although they're expanding to other countries in that region. And we're working with them to, for example, predict demand and ensure that rural pharmacies are always, and even urban pharmacies, are always in stock of essential medicines. Because we know that across Southeast Asia, South Asia, Sub-Saharan Africa, we know that stockouts are a very major issue, which is something that I'll return to when I talk a little bit about the example of malaria. Again, we do want to expand into more areas, thinking about epidemiology and diagnosis as well, but these are the two areas that we're currently working on right now. So now I want to go and sort of switch gears a little bit and talk a little bit more about our platform. So again, like our platform, it is extremely data-centric. We're starting with an SDK, which is the software development kit. We've built one to connect with Android apps because most applications are based in Android. Most mobile users are Android users. And of course, we're also working at the same time on building an SDK for like mobile, not mobile, but web applications. So there's certain organizations that they don't have an app, but they only have a website. And so we, of course, want to be able to integrate with them as well. And it's this whole, I think what I really want to, I'll go through each of these components in more detail in the next few slides. But what I really want to highlight here and reiterate is that this is sort of an iterative process in that, so we're getting in data from the SDK, we're organizing it by defining metrics, key performance indicators, doing feature engineering. And so that's kind of at the analytics level. And then we're using that organized data, those features, we can build models, we can build predictive models. And based on those predictive models, we can construct cohorts that we think will respond to certain nudges in a certain way. Again, as I mentioned earlier, with the context of the nurse who's only using the app at nighttime. That's a very simple example, but with machine learning, with advanced models, we can go much more complicated and construct cohorts which will respond to nudges in different ways. And once we design a nudge, well, we have to run an experiment, right? Again, that's why we're using experimentation with reinforcement learning and other very advanced AI methods, where it's not just a single one-time decision, it can be a sequence of decisions. And we're determining how we can optimize that sequence of decisions. And then we have to do impact analysis, right? So that data is coming back to close the loop. And it's an iterative process. It's not something that we can just say, oh, here's the best recommendation, because people change, motivations change, contexts change, and we have to be very cognizant of that. So again, I'm going to go into each of these in a little bit more detail. The SDK integration it's very, very light. So it's a piece of code that is embedded into our partners' apps. And that allows us to track the data in an organized, transparent way. But we're very mindful that I'm not a data engineer, but our data engineers were very mindful in developing the SDK because we don't want to do something that will endanger privacy of the users or that will slow down the performance of our partners' applications. So we really needed to design it to be as lightweight as possible so that it's sort of running in the background and no one's going to notice. And then we're organizing that data into features that are useful and meaningful to then perform machine learning. And although analytics isn't a core part of our platform, I'll be doing a quick demo in a little bit, and although analytics is not a core part, it's still very useful, I think, and we have some really great product designers and who are working on really beautiful analytics dashboards that our partners will have access to understand at a high level how are users using the platform, their apps. This is the core of our platform here, is the predictions and the model management. So these really go hand in hand. And so we're doing, these are dynamic predictions. They're really time-based. They're very extremely personalized. So we're generating very nuanced cohorts. It's not like manually, you can do, I'll show you can do manual segmentation as well, but really these are advanced cohorts. And based on these projections, we can then send nudges, which I'll be talking about in the next slide. And I think I really also want to highlight the model management, which is showing exactly what models are in production among what users. And I think that's, again, it's our testament to our transparency. We're very cognizant of the fact that AI and machine learning has been used in harmful ways, both for society, for users. And our goal is to not do that, right? Our goal is to be, you use the tool in the right way and ensure that our partners have full control and an understanding of what we're doing so that if they want to stop anything, it's super simple for them to do so. And again, I'll show you that when I get to the product demo. And you can really understand, the idea of model management is you can really understand what's going well with the model, what's not going well, how exactly we're parameterizing the model. And so there's really full transparency. So then once we have these cohorts defined, that's when we can start developing the nudges. And so again, this is where we're combining the predictive power with the personalized interventions. And so partners, they choose to take action on certain subgroups that they think can benefit the most from a supportive message or from an incentive. And yeah. And again, this is it's not a one-size-fits-all thing, and we can't just assume that something's going to work for everyone, which is why we have to run experiments. So we have to say, okay, let's try this on 20% of the sample, or sorry, a sample of 20% of the entire population. Oh, it worked well. Okay, if it did work well, then we can adopt it to the overall population. And because we're sort of continually monitoring it, if it turns out that it stops being effective, that's also something that we have to keep in mind, and then change up the nudge as well. I wanted to talk a little bit about our team here. So we have our excellent team member Bebeto here in the front as well. And I think the team at Benshi is absolutely incredible. I think it's probably one of the most diverse teams that in terms of tech companies that you can possibly imagine, because our CEO and our heads of data science are all women. We have more women than men on the data science team. On the engineering team, it's a little bit more, I think almost 50-50, but still there's significant representation of female leadership at the highest level, which is very, very rare for a tech company. I'm from Silicon Valley, and I've sort of seen this throughout my life. It does not happen. And at this also, we have this team that is, really it's a truly global team. We have people in our Barcelona office that are from Singapore, from Serbia, I'm from the US. We have people working right now in Nairobi and in Lagos, and we're hoping to expand our offices there. So we are very actively hiring, and really I think we want to make sure that we have people that are from the global south, right? That are being, that are thinking about these issues, that are being affected by these issues, to participate and lead these efforts. So that's something that we're really, really passionate about. And it's something that I think really makes Benshi very special. I wanted to talk a little bit about the kind of research that we're doing. So we're a relatively new organization. We're founded just a little bit over a year and a half ago. And one of the ways that we can gain credibility while still starting to work with partners is by publishing research. And so, sorry, I should have made it all at once. But we're really doing research at a sort of spans the gamut of applied data science research and theoretical research. So thinking about causal inference, like how do you measure the impact of an intervention? Behavioral predictions, that's sort of the core of what we're doing. A lot of forecasting comes into play. Reinforcement learning for determining which decisions to take at which time. And we're also doing a lot with synthetic data generation, because we're working with partners, and as we're expanding our portfolio of partners, we want to make sure that our product and our platform is it's sort of up to par. It's good enough even before we have all of that incoming data. So we're generating our own synthetic data using the most it's not something that's trivial to do. You really have to make sure that the synthetic data that you're generating is representative of something that you would reasonably conceive that a partner would give us. And that is allowing us to do a lot of testing of advanced features even before we're integrating with partners or deploying some of these tools on the ground, which again is really powerful because we can sort of run these simulations or run these more theoretical applications of our platform before it's deployed in the real world. Again, we publish pretty extensively. We've published at NeurIPS, which is the Neural Information Processing Systems Conference, one of the most prestigious machine learning and AI conferences in the world. And also we've published at KDD, also a very renowned health and health tech conference. And it's sort of, again, at a wide, there's not just one type of paper. It's really across the spectrum, from thinking about, okay, like data-centric machine learning platforms to actually deploying data science methods in the context of demand prediction or forecasting or reinforcement learning. And actually last year, we won at KDD Health Day. Our heads of data science won best paper, which is really, really cool. So if this is something you're interested in, we have a lot of people that on our team also that have very advanced degrees in math and physics. And so being able to learn from them has been actually a really tremendous experience, because they have all this experience applying these concepts to the real world, to real business problems, to real situations, but at the same time, they have a lot of very theoretical understanding, and so it's really great to be able to straddle both of those worlds and learn from people that have done both very successfully. Before I wrap things up, sorry, I've been kind of talking for a while, I did want to just quickly go through an example that I think hopefully is of interest to you all. This is not something that we're working on right now, and I don't even know if a lot of this is possible right now, given the state of data collection. But I kind of wanted to put this out there to show how I think a data-driven system and a platform like Benshi.ai's can support the fight against malaria, which is as you all know, is a really devastating illness. Most of the deaths are concentrated in children, especially children under the age of 5, and most of the deaths are concentrated, and the cases are concentrated in sub-Saharan Africa. There's some in India still, but really, a huge burden of the problem is borne across Africa. And I'm kind of going to be toggling across two sets of slides here. So the first is areas where we think, there's scope for impact. So when you think about malaria, okay, we think about surveillance, prevention, diagnosis, and treatment. And then there's areas where we think we can intervene reasonably. And again, these are just sort of high-level areas that I'm sort of categorizing. You can go much more in nuance and much more detail. I just want to talk about this at a high level. And there's supply chain management, capacity building or training healthcare workers, thinking about improving patient adherence or patient behavior change, and then also evaluating real-world policy interventions or clinical trials. So again, I'm toggling back and forth here a little bit, but one of the things on surveillance that I find really interesting is that a lot of studies show, so in order to go from malaria, like reducing malaria to actually eradicating malaria, you need to have real-time information on the individual cases, right? So it's not enough to get aggregated level data at a county level, a district level, something like that. It really needs to be individualized. And so in order to do that, if we have that kind of data, that lends itself really well to these adaptive interventions, because you can target resources towards areas of need. You can react quickly by incentivizing the healthcare worker in that area to take action while there's only one case instead of when there's 50, or going to that patient and making sure that they're getting the support that they need. So I think there's really like that surveillance key. It's kind of lines through the other areas as well, but I think it's something that where having granular data is going to be really, really important. Prevention is also something that I think is very interesting. So a lot of malaria prevention efforts are targeted towards pregnant women and also towards like younger children. And there's kind of, again, there's much more complicated than this, but one of the key methods is long-lasting bed nets. Again, I'm sure you're all aware of, and also certain chemo prevention, so certain drugs that you take to prevent malaria. And one thing that has been sort of noted in a lot of the literature and a lot of research is that for example, women who go to an antenatal care visit, so they go when they're pregnant to a checkup, those visits are where it's a great source for giving those patients bed nets. But oftentimes, those clinics are not in stock of bed nets. And so there's sort of this like mismatch. There's a data fragmentation, right? And so even though there's sort of rapid diagnostic tests that have become more and more common, stockouts are still an issue. So on the supply chain side, there really is a lot to do. A lot more that we can do to ensure that the people that need rapid diagnostic tests are able to access those. But at the same time, there's also a capacity building issue. So there's lots of studies that show that community health workers that are volunteers, they're not either or even a pharmacist. Even if you go to the pharmacist, they don't actually, even if they have the test, maybe they'll just, the patient's sick, maybe they just give them the test, or they don't know how to operate the diagnostic test. And so we're working, for example, with e-pharmacy apps that have capacity building modules. So there's really, that is, I think, somewhere where we can get that data and we can support capacity building efforts through digital technology to improve the training and skills of healthcare workers. Sometimes also, like if your child is sick, on the patient adherence side, if your child is sick and has a fever, you're not going to want to wait 15 minutes to take a test. You just want the result right away. So there's also lots of studies that show, can we run incentives? So can we give people financial incentives to actually wait for the test result, and then if it's a negative, give them something else so that that cascade of care is still continued. So this is something that, there's not really a digital app yet, or there's no data source for this, but there have been studies that are showing that financial incentives can play a role in making sure that people get a confirmed diagnosis before receiving treatment. And the reason that receiving a diagnosis is really important is because anti-malarial resistance, so the parasite resistance to the drugs is increasing at a really alarming rate, actually. And also, if you don't have malaria, but you're sick with something else and you take anti-malarial drugs, you might actually make what you have worse. So you have a fever with something else, that might actually get a little bit worse. And then on the side of treatment, so we know that the sort of the first line recommended treatment is artemisinin combination treatment, so that's ACTs. And unfortunately, most people, they purchase drugs in the private sector, and in the private, or this varies from country to country, but in the private sector, artemisinin is very, very expensive compared to not other kinds of anti-malarial drugs. And so I think there's something to be said for thinking about, this is less of a data issue, but really I think thinking about how do we align those incentives to ensure that patients are getting access to the highest quality drugs, and that those are also affordable for them, is something that is really going to be really, really important. I don't think a data-driven platform is going to solve all this immediately, but it is an important issue for us to be thinking about. And we also have issues here where dispensing, pharmacists have been shown to dispense the wrong quantities sometimes. So I think capacity building efforts, again, come back into play. And sometimes patients don't adhere to the entire course of treatment. And so there's something that we can do to ensure that they're making sure that they're taking the medicine that they need to take. So again, this sort of at a very high level, and a lot of this is not necessarily completely possible today, but I think there's lots of areas where better quality data and better understanding of user behavior, better understanding of user motivation, and then being able to actually intervene for those users can make a tremendous difference. I just want to go through a worked example of something that I think is a little bit more feasible. So let's say a patient arrives at a pharmacy with fever-related symptoms, and we want to say, okay, from the supply chain perspective, what do we need in order to make sure that our outcomes are met? So our goal is that we should have the rapid diagnostic test and anti-malarials in stock if a patient comes to the pharmacy with those fever-related symptoms. And so what kind of data do we need in order to optimize this situation? So we need to make sure we have the supply distribution logs, and so that's sort of tracking where things are being shipped to and from. That's not necessarily user behavior data, but it's really important contextual data. We also need pharmacy purchase logs. So again, we're working with these sorts of logs in the context of Southeast Asia right now. But hopefully we'll have more partners in Africa soon. And we also need other contextual data, like I mentioned earlier. So for example, you need to know if there's going to be weather delays. You need to know if there's going to be other sort of political instability or other demographic issues that are telling us that there's certain regions that have highest concentration or at highest risk of a malaria outbreak. And so those regions need to be prioritized. So that contextual data is extremely, extremely important. The tools that we would use in order to achieve this outcome would be primarily demand forecasting and supply chain optimization. And we'd also, of course, rely on those interventions in terms of reminders to distributors and pharmacists. So you can think of this as kind of Amazon reminding someone to make a purchase because they put it in the cart, or that something that they, it's a recommended product based on their previous purchase history. It's analogous to those kinds of recommendations.